Hello, today we will discuss about Man-Instrumentation System. That means we know that different types of devices or instruments are used in case of your diagnosis, for therapy, for rehabilitation, or for your prosthetic. So those instrumentations, they are the bridge in between human body and the equipment. So this system we call it as Man-Instrumentation System, or instruments which are used in your medical practice. Now basically our body is generating different types of biomedical signals and different physiological activities are going on inside our body. A basic medical instrumentation system that can translate physiological phenomena into electrical signals that may be in form of electrical current or voltage, and once these signals has been captured, those signals can be displayed or recorded for clinical interpretation, forming backbone of modern diagnostic and monitoring equipment like ECG, EHD, then pulse oximeter. We have imaging instruments and your different types of medical equipments or instruments. Now this is the block diagram of a basic Man-Instrumentation System. Here the thing which we want to measure, it is your measurand. That physiological activity we need to measure or we take a record of that is known as measurand, and this measurand can be excited or can be measured by applying different energy sources, electric, light, in some cases of infrared, then we can apply some mechanical pressure, and also different types of sensors, they are operating on using these energy sources. We can also apply ultrasound. Then next one we have this calibration. Next part is calibration. Every time we have to take one measurement, we have to send one reference and check whether this equipment is working properly or not, or previously some offset value is there in the measuring device, or we need to make it to eradicate or to vanish that offset value through this calibration process. Similarly, we have sensor transducers, then we have a pre-signal, pre-amplification and signal processing. Inside it also we have some filtering devices, then there is some control system unit, feedback unit is also there. Then once we got that, then we have alarms. We can send that signal for display, we can store that signal, or we can transmit that data, or we can record that data. So one by one we will see what are these blocks of this Man-Instrumentation, of a basic Man-Instrumentation System. Now what is measurand? It is the physical quantity or biological condition that the medical instrument system measures. It may be your pulse, or it is the waveform generated due to the electrical activity of heart, like your ECG. Similarly, the human body acts as a source of measurand, producing various signals. These signals, as we have previously discussed, we have different types of biomedical signals or biosignals, and they are generated from numerous point of different sources, different physiological activities that is going on inside our body. So it can be your blood pressure, it can be electrocardiogram, that is your potential or action potential. These are some measurements that can be the surface signals, and some cases like blood pressure, they are some internal parameters. We can also measure the partial pressure of oxygen, partial pressure of carbon dioxide in the blood. So these are different things we need to measure and they are known as measurands. Next, how to measure those parameters? We have different parameters in different forms, some in the form of chemical changes, some in the form of ion exchanges, some due to the action potential or in form of voltage, some are in terms of pressure, some are in terms of your enzymatic changes or action, some are in terms of current. So various types, some are in terms of magnetic field changes. So different measurements are in different forms. Now we need to convert all these different forms or all these changes with respect to a reference, and we map them to an equivalent electrical signal. So to do that, we require some sensors and transducers. Basically, the sensor primarily detects a physical quantity, whereas a transducer that converts one form of energy to another form that has been measured. So what is the basic difference you mark here? Sensor will detect the change, detect the variation in that physical quantity what we need to record. But once it has been detected or sensed, that sensed signal or that sensed parameter or physical quantity, it has to be converted to its equivalent electrical signal. So through different transducers. So a transducer converts one form of energy to another form. It can convert, like your piezoelectric sensors or transducers, they can convert the pressure into your equivalent electrical signal. So often transforming physiological phenomena into electrical signals. The primary purpose of a transducer, basically sensor transducer, they are working together in coordination. The first part is sensing, the second part is conversion or transduction from one form of energy to other form. The primary purpose of a transducer is to generate usable electrical output corresponding to the measurand. Mark one thing, whatever signal has been sensed, whatever physical parameter has been sensed through sensor, it has been converted to its equivalent electrical signal. Signal we can basically consider either it is a voltage signal or it is a current signal. Okay, and whatever signal we are gathering or we are collecting from the real world signal are maximum or almost all are analog in nature. Analog means they are continuous in time and continuous in amplitude. So if this is your time axis, this is the amplitude axis, they are continuous in both axes. Multiple transducers may be used simultaneously to measure different physiological parameters. So it should be minimally invasive, or we try to make it non-invasive, but in some extent they become minimally invasive to collect or to acquire a better quality your signals. So extract minimal energy from the living system. So this is all about your transducer and sensor system. Next one is the signal conditioning. Now what we get out of this transducer box or this sensor and transducer S&T, they are recorded through the electrodes. Some electrodes are there through which it has been sensed, then this transducer will convert that to electrical energy. This signal, so this signal is one analog signal. So this is an analog signal, either voltage or in the form of current. Okay. So now this signal, it contains numerous noises, artifacts. So we have to eradicate those noises, we have to filter out those noises, and These signals, as they are generated at different parts of our body due to the physiological phenomenon, we are collecting that from the surface of the body by non-invasive electrodes or minimally invasive electrodes. So their amplitude is very low. So basically we may get the electrode values of this signal in microvolt or millivolt. So we need to amplify them. So two things are happening here in this signal conditioning block. First one, once we gather this signal, we have to pre-amplify it so that we can operate on it, we can filter the different noises out of it, and we can make that usable, or we can execute on those signal during processing. So they converts the raw signal into transducer into form of suitable display or recording. May include amplification. This is the first amplification, we call that pre-amplification. Because why it is called pre-amplification? Because this process of amplification stage is before of that signal conditioning or signal processing. So we call that pre-amplification. Then we go for filtering, then impedance matching, then we send that signal for an analog to digital conversion. Then once analog to digital conversion takes place, we send this signal, that digital signal, to a microprocessor or a digital signal processing unit or digital signal processor. Once that signal has been processed, we are getting the signal in digital form, and those digital form we can record that digital form, or we can again convert that through some digital to analog conversion converter, and those analog signal can be displayed on some display or monitor, or we can use them for some different alert systems. So this signal conditioning enhances the system sensitivity, ensures signal accuracy and integrity. Typical component includes amplifiers, filters, rectifiers and transmission circuitry. Now the display system, it is a visual output either in a screen or on a chart, then audible form like alarm, Doppler signal, then display may show data as displacement on a scale, numerical indicators or graphical outputs. They includes additional features such as alarm for threshold violation. It can occur through some programming in that device. Then we can set a threshold. If the required value is below that threshold or falls below the threshold, then alarms will be activated. Data storage for later analysis and communication interface for data transmission. So these are the another two blocks of man-instrument system. Then what are the other support functions? As we have previously discussed, calibration is the ensure measurement accuracy by regularly applying reference signal. Before collecting the signal from our body or the real signal, we have to send some reference signal for checking of all these circuitries, whether they are acting properly or not. That is called calibration. Next one is stimulus system. In some cases, we need to apply external energy or sources to stimulate different organs or to stimulate the biomedical signals or biomedical sources to produce the biosignals. So these are controlled stimuli. It can be in form of light, sound, electrical pulses to elicit the physiological responses such as ECG evoked potentials, EEG evoked potentials. Next one is your control and feedback. This is the main building block or it is main controlling unit of this man-instrumentation system. Automatic or manual loops adjust systems behavior based on measured output through a feedback system. Then modern system often use microprocessor based feedback mechanism. So this is actually very useful for proper measurement and display. Next one is measurement label. This measurement can be made at different organizational levels. We can go for a whole body ECG temperature, functional system, like we can go for measuring the cardiovascular system only, then pulmonary system, organs on cellular or molecular level. We can different measurement level we can set. So basically this measurement types are of two types. One is in vivo, in vitro. In vivo means measurements on or within the living body. We call it as, let's say for example it is intracardiac pressure. But in vitro, measurements outside the body. So we absorb or we collect that signal, or we collect the sample, we measure it outside our body. That is like your blood glucose analysis. Once we collect the blood sample, then we take that, then we go for measuring using some different measuring instruments. So that is outside our body. So it is a in vitro. Next is your intelligent medical instrumentation system. In some cases we call it as IMIS. So IMIS, how this system, how this instrumentation system or instrument will become intelligent. It is a fundamental case that if we can provide the decision making capability and automation system, automatic decision making capability to the medical instrument, then we can call it as intelligent medical instrumentation system. So there are advanced biomedical systems that combines the traditional medical instrument as usual. They have all these Measurand, then we have electrodes. Through electrodes we are sensing different signals, then that sensed signal has been transduced to electrical signal or converted to electrical signal. Then we go for pre-amplification, then filtering, then analog to digital conversion, then we send that to your microcomputer or microprocessor or digital signal processing unit. Then we send that, after execution or processing, we send that to again from digital to analog converter. Then we record it. We can take a graph of it on a paper, or we can transmit it for communication. So this is the basic human or basic man instrumentation system, traditional man instrumentation system. But if along with that we can implement or we can additionally use artificial intelligence, real-time data analytics to enhance the healthcare quality, then diagnostic precision and patient management, then this device is called intelligent medical instrumentation system. The goal of intelligent medical system is to integrate sensing, processing, decision making within medical instruments, enabling them to analyze physiological data autonomously, independent of human intervention, and assist medical professional in making evidence based decision. So both things are important. Intelligent means it have the capability of taking automatic decisions. So these are the layers. We have physical phenomenon, then sent to transducer, then we have a signal conditioning block, then data acquisition system or board, then we have this computer along with the softwares, which are different algorithms, which runs different algorithms to take decisions depending upon the recorded data. Then how to interface this analog signal to microcomputers? Basically it includes multiplexer. Here we have multiplexer, then those analog signal first put into the multiplexer, because we know that multiple number of signals are captured through different sensors and transducers, and all are sent into the multiplexer. At a particular instant of time, this multiplexer will choose only single input which on which we can operate or which can be executed. That signal is then sent to the buffer amplifier for amplification, and this amplifier is also useful for impedance matching. Then that signal, we require that signal to be sampled and quantized so that analog to digital conversion can take place. So this sample and hold circuit, this will create the chopping of your signal at different instant of time, and then those signal is sent to analog to digital converter. And now we are after passing through this analog to digital converter, we are getting multiple bits of that signal in digital form, 1 and 0, sequence of 1 and 0. Then those signals will be then sent through tri-state drivers having 3 different states, then high, low and high impedance state, that is Z, means 1, 0 and Z. Z means disconnected. All components operate under interface logic control to ensure proper sequencing and timing. Now all these devices, all these blocks are controlled through some control logic. As we have discussed, these multiplexers, they can select only single output from multiple number of signals, and it operates in a random or sequential selection mode, allowing real time responsiveness. We have buffer amplifiers. As we have discussed, these buffer amplifiers are useful for impedance matching and noise rejection, and they have the high input impedance like at about 100 mega ohm to prevent signal distortion. Programmable gain amplifier allow dynamic adjustment according to channel selection. Then we have sample and hold circuit. It captures and maintain a constant voltage during analog to digital conversion, and essentially for high resolution or rapid changing signals, and it omit in low frequency application where input variation is minimal. Then those signals, as we have already discussed, after it is passing through that sample and hold, those samples of the signal is then sent to the analog to digital converter, which are available at different resolutions. It can be 8-bit ADC, it can be 12-bit ADC, it can be 16-bit ADC. Depending upon that, we can choose. Depending upon the application or the requirement of the resolution, we can choose different types of analog to digital converter. Then key parameters of this ADC are resolution, then accuracy in conversion, linearity, whether it is working linearly or not, then offset error. This offset error must be minimized for this ADC conversion. Then gain error, conversion speed, how much time it will take to convert from this analog signal to digital signal. So all these parameters are important while choosing the analog to digital conversion in a intelligent medical devices. Output is in parallel digital format for microprocessor interfacing. So basically after ADC we are getting a digital sequence of 1 0 and or 0 1 form that has been put into bus of a different data bus of this microprocessor. Then tri-state drivers, as we have already discussed, 3 states are there, and control logic is synchronizes timing and control the acquisition process. It generates control signals such as start of conversion and end of conversion, means SC and EOC, ensures correct analog channel selection, sampling and conversion sequence. Finally, the output is again can be recorded from digital to analog conversion, and output of this digital to analog conversion will be an analog signal. It converts digital signal back to analog for external use. Utilizes digital to analog converter for current and voltage outputs, and those outputs, analog output, it can be displayed or recorded on an oscilloscope or chart recorder. So this is all about Man instrumentation system. or man instrument system. Thank you.